Welcome everyone to the IPLD Sync and Community Call. It's every 4 weeks, and today it's April the 24th, 2023. And yeah, as every 4 weeks now, we will go over the stuff that people worked on, but also here's some talk, or even also if you have questions. Or also, if you want to present something, just let us know. We are still searching for people to present things. It doesn't need to be really about like building core things for IPLD, but it could be just like cool things building with IPLD as well, of course. All right. Well, let's see. Should we start with the presentation first, or I don't know? Rod, would you want to start, or?
No, let's see what has anyone else got anything they would like to present or talk about?
Yeah.
I mean, I think one thing, Rod, that maybe you'll talk about, but that I suspect is something that comes up over the next week or two, is that there are going to be at least two efforts likely working to do traversals in various ways and thinking about validation of cars in traversal order. I know Jeropo expressed interest last week in extending the car spec to talk about what a ordered car was. So that currently IPFS, I think, has some ways where it can write a car without any guarantees of the blocks being ordered. And I don't have a complete sense of what the unordering is, although I believe it comes from BitSwap things. And so based on, it knows what its set of blocks that it has outstanding, it's asked for them. If a peer for a later block gets it first, it'll write that block, even though it's later in the sequence. And so that's the sort of ultimate source of where blocks may come in potentially unordered right now. And then I think Jeropo has a UnixFS to car or like Linux to car binary that just does mapping based things, but wants to play some tricks that would result in the file also being unordered or having some interesting ordering properties. However, as we look at the HTTP gateway spec again, and so thinking about the trustless gateway, in order to get incremental verification, you again want your blocks to be in an order that allows you to do that incremental verification. So I think there's work that both Adine is going to do and that also Lassie, that I think we'll hear from Rod, is maybe going to look at about you get in a car file and you want to be able to incrementally verify it as you get it. And so based on my current understanding of code, that likely means there's both an IPLD format / Go Merkle-DAG and a Go IPLD prime variants of being able to read in a car stream and incrementally verify it that come out of those paths of work over the next weeks. So with that, we hopefully end up having a spec discussion about what an ordered car is in order to do such verification as well. I suspect there will be some GitHub activity around that topic.
Yeah. Well, one of the reasons I put my hand up to present something is because there's actually been a lot of activity around IPLD just coming out of this gateway work, and we've been really thick in it. Which is really exciting because for the past while it's been a bit more difficult to justify working specifically on IPLD because there's so much other stuff to do. But we've come full circle as we start to do retrievals from Filecoin and then integrate that in with this broader notion of IPFS retrievals. It's given us a lot more opportunity to do IPLD stuff. Anyway, do people want to hear my little ramble about the work we're doing with Lassie? Okay, so I'm going to share Okay, and now I have this as a markdown presentation, and I'm not doing this. I promise I'm not doing this to be a hipster. I did this last night really quickly, so you can follow along in my little markdown presentation here. I'm going to scroll through this and talk through, I'd love to have this be interactive. If folks want to ask questions or comment on the way through, then please interrupt. I'd love to clarify or go deeper into things that folks find interesting. And I've also, I can poke around in code if folks want to see anything in particular, but hopefully this is broadly explanatory, and you can go and find out more if you're actually interested. It is, yeah, so Lassie is on GitHub under the Filecoin project org. Lassie is a universal retrieval client for IPFS and Filecoin. So it's focused on retrieving. It's technically an IPFS implementation, but it doesn't store or publish data. So it's not a reciprocal node. It's a client that fetches. And the name Lassie is so that we can do things like Latin fetch. So go and fetch me my data. It's IPLD native, and it only deals in IPLD blocks as car format. So it stops short of doing anything fancy with the output. It leaves that up to you. It's got a fairly strict boundary of responsibilities. So yeah, so that's what makes it interesting for IPLD, because it is very IPLD heavy. It's written in Go, and it offers three things at the moment in one package. So there's a command line utility. You can download binaries or install it using Go install straight off GitHub, and then the main way to interact with it is this Lassie fetch command. It also offers a minimal IPFS gateway-like HTTP API, so you can run it as a daemon. And there's an API that's roughly similar to an IPFS gateway that will allow you to fetch content through that. So you can use it as a like an IPC with another tool, so you don't have to integrate it so deeply. And then there's also a Go library interface where it makes sense to connect in with existing Go code. It's also a work in progress. It's under heavy development, but it works great right now. It is the best way to fetch from Filecoin in particular, and we are busily making it the best way to fetch from any IPFS protocol. So yeah. So why are we doing this? Well, it started as a Filecoin retrieval tool. Our team was focused on Filecoin retrievals, and this is a way of pulling together that work. Its code has history in Jeremy's Fill client, which is sort of integrated into the auto retrieve code for bridging IPFS to Filecoin. So it's some of the code legacy traces back to there. Now we've expanded support for the protocols, so it now supports it supports GraphSync, BitSwap, and we're working on a verified HTTP car support, which is what Will was talking about, that I'll talk about a bit more about later. So it can talk to Filecoin nodes and IPFS nodes, including Elastic IPFS. It now serves as the backend for the Saturn network. For Saturn is a CDN network built on top of Filecoin and IPFS, and it's the backend component that fetches content from IPFS and Filecoin, so that it's serving inside of Saturn some very heavy traffic, and there's ongoing work to replace the IPFS gateway, replace a large chunk of the IPFS gateway, existing IPFS gateway, with a Saturn backend. So there's this ongoing work that is pushing a lot of this stuff forward, that's driving performance needs and specifications and all sorts of interesting things. Lassie is very lightweight. So there's one of the purposes it serves is being something that is very lightweight and small, which is not something that you can currently get with the tooling around our ecosystem. If you want to do IPFS fetching and generating a car from a DAG off IPFS, you got to grab Kubo and run a node and do all this stuff, and it's very heavyweight, whereas Lassie is intended to be lightweight. There's currently no config files. There's a lot of command line options and library options that you can run. You don't run a local IPFS node, depending on how you define that. There's no persistent storage. It shouldn't leave a trace except for what you've requested. And it's very fast startup time. It'll get going very quickly. And it's got just enough functionality to get IPLD content. We, as I said, we keep the boundaries of its functionality fairly tight when we're trying not to span too far beyond its core remit. How? So we don't run a node, so we're not out there doing constant discovery, and figuring out where to get stuff off Filecoin is not the most straightforward thing. But there's the Filecoin and IPFS network indexer service, which we integrate with. So we rely on the indexer service to do the content discovery for us. And thanks Will and team for all the work on the indexer, because that we get to completely put aside that discovery side of the question. So the indexer can tell us where content is. So a Lassie fetch will query the indexer with the CID, and it finds, first of all, it finds Filecoin storage providers, because it has a record of Filecoin storage providers that have advertised their content onto the indexer service, and we can get a list of those. And then it also queries, the indexer can query the DHT for us, so that we can ask it to do DHT discovery for us, and it'll find nodes that have the content. So Lassie will begin graph sync and or bit swap sessions to retrieve content from peers. And we're working on HTTP fetching as well soon. That's a work in progress right now. So it'll work on multiple protocols. Currently, it does a race, but we're working on more sophisticated ways to do multi-protocol chatter. And then it'll request the data that you want as a graph. So you request a CID, but you also request, you have ways of requesting graphs. So there's multiple things going on here. You can request a path. So there's CID plus path. You can request the entire DAG under a CID, and it'll fetch everything. You can request just the CID and or the path, so that just one little block that you're pointing to, or you can fetch just the UnixFS entity under the root and path. And I'll explain that a bit more later. But there's these three different modes of fetching, of describing a graph. Our code currently also does, if you use Lassie as a library, you can do arbitrary selector fetching as well. We're not sure if we're going to continue to expose that in quite the same ways. Arbitrary selectors are quite hard, but there is still currently support for fetching according to your own custom selector. We may retain that in some form. It's hard to do arbitrary as well as all the very specific things we want to do, and there's a bunch of other problems with arbitrary selectors, so that's up in the air a bit. And then the content is returned as a verifiable car, so we only deal in cars, and they're structured to be verifiable, and it turns out to be a perfect partner with GoCar, which we're also developing in tandem with Lassie. So you can fetch with Lassie, you pipe the output car to GoCar, which you can then extract the data, and then you could even pipe it onto something else. If you didn't just want to extract files, you could pipe file content onto something else. So these tools work really nicely on the command line, particularly when you're working with UnixFS file data. So on specifics on the DAG forms that we're selecting. So as I said, you query primarily with a CID and an optional path. That's the primary mode for dealing with Lassie, although there is still this ability to do your own selector. So you'll say, this is my CID and a path. It'll start at the CID, and it'll walk the path that you've asked for according to IPLD pathing rules. There is a caveat there that I'll come back to, which is that the default, it will default to UnixFS pathing semantics where possible. So I'll explain this in a minute because I find this interesting. Others may not, but there are two different ways of doing pathing primarily with IPFS. One is plain IPLD pathing, where you path the nodes in blocks, and then the other one is pathing according to UnixFS semantics, where you path according to the named links in a UnixFS graph. So we will default to UnixFS because that makes sense for most of the content we have to care about, but it will fall back to plain IPLD pathing if it can't figure out UnixFS pathing for what you want. So single block fetch, as I said, is just give me the block, but give it to me at the terminus of the path, so I can specify the path to the final block that I want. You can fetch the entire DAG underneath the path if there's a path. Or this entity fetch, which is I'm calling it UnixFS entity fetch. We don't have a great name for it. There's various names for this in code and in specs, but what I'm calling entity fetch is give me the UnixFS entity at the terminus of this CID and path. Now, an entity can be defined as is it a sharded file? So, is it a file? There's file or directory with UnixFS. Is it a file? Just give me the whole file. If it's sharded, that is, if the file is spread across many blocks, then give me all of the blocks of that file, which ends up being the complete DAG. But it's like, I don't know what this is. You just give me the full thing that's here, but no more. Because if it's a directory and it's a sharded directory, well, if it's a directory and it's not sharded, then it's just a single block. So you get a single block in that case. But you don't get the leaves of the directory. If it's a sharded directory, then you want to get all of the blocks that make up that directory, but not the leaves. So basically, I want to be able to do an ls on the directory, but I don't want to have to open the files in the directory. So this is the mode you can use for that. So UnixFS, but the reason we're doing UnixFS by default is at least 95%. This is always a guess, I don't know, but at least 95% of the content stored on IPFS and Filecoin is UnixFS. So we just assume by default that you're using UnixFS, but an increasing amount is non-UnixFS. People are making their own formats, and we will probably see formats like WinFS expand, which will not be UnixFS. So for now, anyway, UnixFS is like table stakes that people expect. So we say we'll try looking at this thing as UnixFS, but if the blocks we get back are not DAG-PB, or they are DAG-PB and we can't interpret them as UnixFS because they don't load as UnixFS, they will default back to just plain IPLD semantics. So, excuse me. Pathing on UnixFS lets us do named paths. So if I say path to thing, the actual IPLD path for that on a UnixFS block, on a set of UnixFS blocks, is really ugly. It's you navigate into the block, and then you go into the links array, and then you choose the index in the links array you want, and then you go to the link in that index, which is called hash. So you end up with this ridiculous looking path that people do use, but it doesn't. You have to know ahead of time where the named links are in your blocks, so you have to know the indexes of them. So the fact that we can default to UnixFS lets us use these names that people have encoded in their paths, because people's directories and files have meaningful names. So so we can run our pathing over that, which is pretty neat. So the back to the entity fetch thing. Sharding is really the problem here that we have to solve, because often files are bigger than safe IPLD block size. So people have files that are bigger than 1 or 2 megs, and a UnixFS will encode them in multiple blocks and then pretend that it's a single file. Well, it is a single file, but it's spread across blocks. So that makes it complicated. When people say, I want to fetch this thing at the end of the path, they don't typically, if they're giving you a plain path, they don't typically mean I want just the block. Because if they're like using this through a gateway, or they're expecting a page and the page is huge, they want the whole page. They don't just want the block, because that might only give them part of the page. And the same with directories. When directories grow over some size, then they become sharded and they turn into a hamped, and we get this really complicated tree of blocks to describe a directory. So as I said, the directories are an interesting case, because the hamped could end up being quite large. With a sharded file, it's sort of a bit more linear, but with a hamped, it's just this sort of web of DAG that you need to have the whole lot of it to be able to look inside everything. But you don't always need it. So we can path through a hamped to get to somewhere else and just pick out the pieces along the path that we want without getting any more blocks than we need. So there's nuances to the way this pathing stuff works. But the thing I wanted to talk about was how we're achieving this, because the logic of it all is very complicated. But we get to in the code, we get to hide a lot of the complexity by using ADLs, which is quite exciting, because as with a lot of the other stuff we're doing with Lassie, we're actually building on top of the IPLD prime vision of IPLD, which Eric's been working on for, I don't know, 5 years. And it feels like when I'm working on Lassie, it feels like we're pulling together so many pieces of Eric's vision for IPLD and instantiating them in this final form that is sort of, it's validating a lot of the work that Eric did finally. A lot of it, IPLD prime is used heavily all across the stack, but it feels like in Lassie we're pulling it together in a very like we're putting lots of it together. So ADLs are this concept we've been working on for a few years, and they've been variously applied, mainly UnixFS through the Go UnixFS node, which Will has had a big hand in developing. So we get to use UnixFS as an abstract data layer, where we say to the traverser and to other components, we say, when you get to this thing, we want you to be able to see it as UnixFS, not as plain IPLD. So basically it's a lens. Like when you get to these blocks, put these glasses on and you view it in this way, rather than viewing it in the default way that you want to. And that lets us do all these things with the path, the UnixFS pathing, but also this entity fetching thing, where we get to use all the tools of IPLD prime, but when we get to UnixFS, jump into this different mode where we say, well, now you're dealing with something special, so we want you to traverse according to these rules. And so it'll do things like it's traversing across the CID and get to a path, and this path segment called path, well, let's say thing, a path segment called thing, it'll get to a block that has these, and it'll know to traverse these 3 different nodes within that block, because the UnixFS ADL will load the block, look in it, and figure out where thing is. So thing is a name of a link within that array, and it'll figure out which one to go through, and it'll skip. But it'll also do other things, like if thing was a directory within a file within a sharded directory, it could be multiple blocks deep. So a common place we see this is when people are using Wikipedia over IPFS. When you get to into Wikipedia on IPFS, and you get to, you go to /wiki/en, or maybe it's the other way around, en/wiki, and then you go /something, and you name a page you want to view on Wikipedia. English Wikipedia is so big that and it's a flat directory. Like every page is in the same directory, so that gets sharded as a big hamped. And to navigate through those pages, you're like, just to get to a single page there, you end up having to jump 4 or 5 different blocks to get there. And so, but we get to transparently do that in all our code, in our traversal. We don't hit this and it's like, oh no, it's a complication. What do? We just say, this is UnixFS, figure it out. And and it will figure out how the path through the HAMT to get to the page you want, as deep as it is, which is great. So so this is proving the power of ADLs applied to this stuff. There's still obviously a lot more work to do on this layering aspect of IPLD prime, but it is working really nicely for UnixFS. It would be interesting to see what would happen when we have other ADLs to apply. I've been toying a little bit of that in some of my spare time, but hopefully we'll get there where it's not just, hey, we need to be able to do plain IPLD or UnixFS. There might be some other thing that somebody shows up with saying, hey, I want you to interpret this as WinFS or as something else. And then we've got to figure out how on earth to plug that in. Because currently UnixFS is a special case, like really a special case to everywhere in our code because it's so common. Okay, and deterministic and verifiable cars, this is what Will was talking about at the beginning. This is ongoing work now. We've been doing this in Lassie since the beginning because we get this free using IPLD Prime's traversal engine. So the cars we output are what we call verifiable, and they're also deterministic. So UnixFS node provides the deterministic UnixFS traversal. IPLD Prime provides overall deterministic traversal. So for any DAG, you know, we will always traverse the tree in the same way. Whenever you encounter it in, you know, different times, it's not going to, there's no randomness here. There's no, you know, latency doesn't impact the order of the blocks that you get out of Lassie. It's always the same order. They're also verifiable, which is really neat. And this is now being spec'd, but it's something that we've needed for a long time. So what this means for content, the easiest way to think about why you would want something to be verifiable and what it means to be verifiable is to consider currently what we have with the IPFS gateway. So if you load a thing from the gateway, and the most obvious example is something with a path particularly. So you give it a CID and then you give it a path to something. So maybe it's a page and it gives you the HTML and you're viewing a page. Yay, I've got it. How can you verify that that page you got is in any way related to the CID that you asked for? You can't. There's no way for you to do that. So whenever you use an IPFS gateway, you offload all of your trust to that gateway and you say, I trust you entirely that the content you're giving me is in any way related to the CID that I asked for. Which is a bit unfortunate because the whole thing about content addressing is that you're supposed to be able to verify it. In theory, if you didn't ask for a path and you just asked for a page, you should be able to verify it by repacking the page and checking the CID. But given the way UnixFS file packing is not deterministic, you can pack files in different ways. That's not always going to be possible. The file might be packed across multiple blocks. It might have different chunking, all that sort of stuff, and you don't know that. The gateway doesn't tell you that. There has been work to work on this previously, but now with all this work around Saturn and this distributing of the gateway stuff, we're really truly specifying this and working on it in multiple places, as Will said. So Lassie outputs these cars that that include the CID that you requested, regardless of whether you had a path or not. It'll always give you the CID you requested and every block along the path that it needed to load. So if that's Wikipedia, then there's like 4 blocks in there through a HAMT, as well as any blocks before that to get to /en/wiki. So it'll give you the route and then every block along the path and then the content that you asked for. So the way you can establish trust is, well, you for some reason trusted that CID you asked for. So you have reason to trust that CID is what you wanted, whatever that reason might be. But given that you have a trust of that CID, you can then verify that that block for that CID exists in your car. So you can check the digest of it and multi-hash and figure out, yes, that's what I wanted. And then for every block along that path, you can check that next block is included in the block that you trust, and you can verify that, et cetera, all the way down to the content that you wanted. So suddenly you have this chain of trust from the CID that you trust all the way to the content. And you can say, hey, I got what I wanted. And so you can do things like use go-car as a coupling to this. So Lassie will give you the car, and then you use go-car to extract your content in a way that will verify trust. We've still got some work to do on that. I'll mention that in a minute. So basically, the CID is your trust anchor. You trust it for some reason, and then you can transfer that trust down through the entire DAG. So you get this magical property of verifiable and trustable content. Okay, another interesting thing that we've been doing that I thought was worth mentioning was some parallelism with fetching. This is a challenge when you're doing deterministic DAG traversal. Deterministic DAG traversals, when it's just one way to traverse, and Will mentioned this as well, is difficult because the network doesn't always give you the blocks in the order that you want them. Because some blocks might be smaller, or they might be closer, or whatever reason, you could get, if you were doing a full parallel, give me everything thing, then you'd get blocks out of order. But because we want to do deterministic DAG traversal, we have a specific way of doing it. We want to assess which block to load as we get them. So we get a block, we look in it, and figure out where to go next, and all the way down that chain. And that's 1, 1, 1, 1, 1. It's a very serial process. GraphSync as a protocol works around this by having parallelism built in, because it's a single peer talking to a single peer. They establish an agreement about what they're talking about. Here's my root and selector. And then they synchronize the blocks between them. And they have this way of doing multiple blocks at a time. You don't have to go back and forth one at a time. It's this shared agreement about what you both have, and then give me that stuff. But it's only a single peer to a single peer. So it's great for Filecoin storage providers when you're fetching from them, but often the content you want is across many peers, and often the best performing way to fetch content is across many peers, because you don't just want to rely on some individual's pipe. You want to have lots of them, like a BitTorrent. So BitSwap is multi-peer, but there's no graph awareness with BitSwap, which is annoying, because you can't make an agreement with a BitSwap peer to say, we're going to talk about a graph here. You just have to fetch the blocks and figure out the graph yourself. So you have to figure out what you're getting next. So BitSwap with deterministic DAG traversal means that you're stuck in this serial land. So what we did is built a pre-fetching parallelism for this traversals for use over BitSwap. So what we do is we have a selector that has rules that it will pass a particular way over the nodes in a block to figure out where to go next. So when we get a block in our traversal, we do 2 passes on it now. So we do it with a selector. The first pass will stop at the edges of the block and just say, these are all the links in the block that we are going to visit next. So for this block, we will be visiting all of these links eventually. And then it comes back and does a second pass where it will follow the normal rules, where it will go down that first route to the first link it wants to jump across to do the traversal. And it may come back again and do the next lot, but that's still part of the second pass. So it'll do this sort of recursive, depth first traversal, where each block gets 2 passes. And the second pass is the normal traversal pass. But the first pass, it allows us to say, for every block, here's a full list of links that we will want to traverse when at some point during the traversal within this block. So we get to build up this list of blocks that we are going to need eventually. So we can put them aside and say, let's pre-fetch these, because we know when we come back, we'll need them again. So then we get to parallelize BitSwap traversals. It doesn't always work, because sometimes there's not a whole bundle of blocks. A DAG can just be a single line, like a blockchain backbone that doesn't go anywhere. So sometimes you don't get the opportunity to, but often, particularly with UnixFS, you're fetching a DAG that fans out nicely. So you might be following a path down the left side of a graph, and then you work your way across. But at each point, there's this branching that happens where you have these lists of these blocks that you're going to fetch eventually. So we can pre-fetch them, put them in a temporary place. And then eventually when the selector comes back and says, I want this next block, we say, well, we already have it. So this gives us the ability to parallelize bit swap for deterministic DAG traversals, which is neat. It has some difficulties. There's some limitations to this. Doesn't work so great if you're working with Lincoln node budgets, which we currently are. I think we're going to have alternative strategies for this, but we currently the way that we are using Lassie in Saturn in particular has link limits. So don't give me more than 10 blocks or whatever it is. We've got a block limit. So this preloading has difficulty with that. But in a normal mode, you wouldn't. Budgets are sort of like a specialist case. Anyway, so preloading is currently available in IPLD Prime Master. It's not in a release version, but we'll get it released. And some of the tooling for working with the preloader and managing block loads is currently living in Lassie, but we'll pull some of that out and put it into IPLD Prime so anyone can use this. But this is really neat because it's been one of the criticisms of deterministic traversals with IPLD Prime is that you can't parallelize it. Well, now you can. Lassie and Go-Car, as I said, these are a great pair, and we're working on them actively together. So you can do things like Go-Car verify, car inspect, and you can check that a car has, you can verify the blocks in it. And particularly car extract to work with the UnixFest content. So you can pipe to car extract from Lassie, or you can just car extract a Lassie car and get your UnixFest content out of it. So we'll work on both of these over time. Something I would particularly like to do is have this this verified car stuff encoded into Go-Car as well. So if we say Lassie produces a verified car, you should be able to verify it easily with another utility. So you could say to Go-Car, this is a verified car. Make sure it is actually verifiable in the way that it's described. Currently, it'll verify the DAG. So a car extract will actually verify the content for you. But we should do some more work to make that more explicit. Finally, as Will talked about as well, this IPFS HTTP transport is currently under specification, and it's a new transport. This will be a third transport in Lassie, so you'll be doing GraphSync, BitSwap, and HTTP, and it's for sending verifiable cars over HTTP. So this nested, verifiable car chatter going on where a peer might be able to give you a car that's already in the format that you want. So which is great. I think Elastic IPFS by Web3 storage will be doing this, I presume, where we will query the indexer, and the indexer will say, hey, this peer over here does this transport, transport IPFS gateway HTTP. And we'll say, great, we don't have to do BitSwap or GraphSync with them. We just pass on the information. Here's the CID and the path. Can you give me that, please? And here's the DAG traversal type that I want, and it will give you a car, and then we can just pass that on to the user. But what Lassie will do, it will do its own verification of, has the peer given me the car in the way that I want it, and does it include all those trust properties? So it'll be like we'll be able to talk to gateways as well. So Lassie can sort of act like a gateway. And it will be able to talk to other gateways, and there's this neat recursive thing happening there. But that's a work in progress. Anyway, that's the end of my notes. I hope that was interesting. There's a lot of IPLD stuff in there. If anyone's got questions, I'd be happy to hear them. I could poke into code. I'm not sure that'll be so interesting, but if anyone's interested in that, let me know. There you go. Questions, comments?
Thanks. I'm super happy to see how things come together, after all those years.
Yeah. It really is. That's one of the most exciting parts of this. Is finally feels like we're pulling these things together. A lot of this is thanks to the great work by both Hannah and Will have been particularly champions in pulling this stuff together. But it feels like we're just making use of all of these things and really proving it. it's quite satisfying. I wish Eric was still around to make the most of it, but he's off on other adventures, still using IPLD, but not as deeply in the core of it.
Any other questions or comments? Then I might go quickly on. So it's not something that I've worked on, but just some information for the people that work in the Rust IPLD ecosystem. There has been a huge refactoring of Rust's multihash. On the master branch, it's merged. And so if you're using multihash somehow, it would be great to try out the master branch because, yeah, as I said, so it's now also different crates and so on. And it should be fairly smooth to upgrade. We don't have any documentation yet, but so before we do a release, there will be proper documentation about how to upgrade. But it should be straightforward and just to see. So because like I'd like to see before I do the release actually to see like if it works for people or if we've missed some cases that people use multihash and we haven't catched. And the idea, so the background is the problem obviously is always if you do, it's still developing, if you do some changes and then you have breaking changes and then you need to upgrade and so on. So now really the core of Rust multihash is really only the kind of like the multihash type. And the whole codec table and so on is moved into a separate crate. So for example, like if we add a new hash function or something or remove one, it's not a breaking change for the core part, which probably many people will only use. And also one point is the original idea from current implementation of Rust multihash is that everything is stack allocated, which makes it quite difficult to use, but that is due to being stack allocated. But also that the idea always has been that you create your own codec table for the hashes that you actually use. But people basically just kept on using the bundled one. And now as the bundle is kind of like separate, hopefully people think, oh, I don't want to have this huge bundle in my build. I make my own codec table. So we'll see how this works out. So that's just the background. It's linked in the notes. Or actually, I just go to the master branch. Any feedback is welcome. All right. Does anyone have anything else or want to share or talk about or have questions?
Related to yours, but with Python, there is a discussion currently happening about the Python libraries, and where somebody's contributed a page for IPLD.io that lists Python libraries that you can use for IPLD, and they've developed a DAG-JSON codec for Python, which is great. But I've been actively deprecating some of the sort of a non-core core in the sense of this is what Protocol Labs mostly cares about, which is JavaScript and Go. Non-core language libraries under both IPLD and multi-formats, because a lot of them are not actively maintained. We don't have trusted maintainers to take care of them, and so they collect issues and pull requests that don't get responses, which is not great open source. So instead, I've been archiving them so people know these things aren't actively maintained. But if you want to maintain them, then fork them and also contribute links back to our documentation, which somebody has done for Python. Now I've opened up an issue on the multi-formats org, which I've linked in the notes here under the Pi multi-codec repo, just to see if there's anyone around that is on the existing team there that is actually maintaining it. Otherwise, I'm going to deprecate all the Python libraries in multi-formats, and I think I've already done it in IPLD. And then the new page on IPLD.io will link to external libraries, and one in particular that folks seem to be using is a multi-formats library that is in the Hashberg.io org. But there seems to be some interesting activity on Python. So link in the meeting notes.
Thanks. All right. If there's no further questions, I will close the meeting and also say when the next one is. It's kind of currently a bit of a manual process on to publish them everywhere, but let me quickly check. So it will be, yeah, I also thought about like it's probably a good idea. So I like the idea of doing it every 4 weeks instead of monthly, because like perhaps like someone has exactly on this Monday in the month no time. So if it's every 4 weeks, people might have a chance to join. So so we are rotating. So let's see, it will then be the 1, 2, 3, 4. The May 22nd will be the next meeting. But yeah, I will put it on the channel and also on Luma and wherever those things are. All right. So thanks everyone for attending, and see you all in 4 weeks. Bye everyone. And as always, feel free to hang out for the after party, obviously. Yeah. All right.